Welcome everyone. So in this video I'll be discussing on some major operations that are used in real life while working with Pandas data frames, and I'll also be talking about some data input and output commands for inputting data from CSVs and Excel and outputting them in CSV and Excel formats. So let's start off by importing Pandas as PD, and here I have made some data frames already. So in order to save time, because I've already covered how to make data frames before, so for different sections of the video I have different code blocks. For now I'll be running the concatenation code blocks. So here I have created three data frames: data frame 1, data frame 2 and data frame 3 with their columns and values. So if I run them and show you what df1, df2 and df3 look like. So df1 looks like this, df2 looks like this, and df3 looks like this. So here you can see all the three data frames have the same column name, whereas the indices are different for each. So now let's call the pd.concat function in order to concatenate the data frames together. So if I just pass in df1, df2 and df3 and run this, you can see that I get a data frame from index 0 to 11, which where data frame 3 has the last index as 11 and data frame 1 has the first index as 0. So this is actually concatenating by the indices. So if I look at the default parameter, you can see that axis is equals to 0. So if I want to concatenate by the column names, I'll have to pass in axis equals to 1. So running this, you can see that there are three data frames over here with column names ABCD, ABCD and ABCD. So these are df1, df2 and df3. And when I run concat over the columns, you can see that only the indices which were present in data frame 1 are shown from 0 to 3 for the ABCD columns at the first ABCD columns, and the rest indices are NaN because they didn't have any value. So the indices run from 0 to 3 in data frame 1, so that's why the rest of the values are null. So similarly, that's the same for data frame 2 and data frame 3. Now let's talk about merging data frames. So let me run the merging code block. So if I run this, and here you can see that I've created two data frames, left and right, and here I have a column named key with exact values with similar values in both of the data frames. So this key is going to be the column where I merge the data frame. I'll understand that with this example. So I'll call pd.merge, and then let me first show you what left and right looks. So these are the data frame names. So left looks like this and right looks like this. So now if I call pd.merge on them and pass left and right, and then if I pass how equals to inner, this is going to be merging by the inner parameter. And if you are not familiar with the inner parameter, just leave it for now, but I'm sure some SQL users are known to this. Now the one thing that I want you all to focus on is the on parameter. So on basically the on parameter basically gives the column name on which the data frames are to be merged. So for this I'll be selecting the key column. So key, you can see in both the data frames the key has the same values. So if I run this, so this is our merged data frame. We have different columns A, B and C, D, but the key column has been merged together in order to create the data frame. Now if we want to join the data frames, let me quickly go over and just run this. So here I've made a data frame named lefts and rights. So they have different indices values. So let me show you what they look like. So lefts looks like this and rights looks like this. So here you can see I have different column names and different indices. So data frame lefts doesn't have any index k3, but data frame rights has index k3, but data frame rights doesn't have any index named k1. So now let's call pd.join. But actually in pandas you do not call the join function using the pd.join, but instead you call it of the data frame. So lefts is our data frame, and you pass in the another data frame rights as the parameters in the join function. So if I run this, you can see that I've got a new data frame, and here you can see that the indices are actually the indices of the data frame that on which we are calling join. So lefts is our data frame, and here we have k0, k1, k2. So the new data frame will also have the indices k0, k1, k2, and here you can also see that we've got null values in column C and D, which are of data frame rights. So here we do not have any index k1. That's the reason we're getting null values over here. And as you can see, k3 has been dropped. Now let's move to some other exciting parts of pandas. So for this, let me run this block of code. So here we are just creating a data frame with columns, and we have named those columns as column 1, column 2, and column 3. Let me show what this data frame actually looks like. So if I run this, this data frame looks like this. So we have column 2 with 2 duplicate values over here, 4, 4, 4. And what I wanted to illustrate with this example is that if I call a column, so for here I'll call column 2, and then use the unique function, then it returns me only the unique values of the data frames. So this is widely used in real life datasets where you need to find the unique elements of some columns. For example, in the one dataset that I've just recently worked on was the Open Data Nepal dataset. So I had worked on a poverty dataset, and there the unique column, the one column had a different value of measures. So for example, that column had number of poor, percentage of poor, and people, something like that. So I wanted to, and they had multiple instances of the same values. So for example, number of poor were repeated almost 1,000 times, then the other parameters was also repeated 1,000 times. So what I did was call the unique function and got the strings which were in that column. So that's a pretty good way of using the unique function. Now if you want the number of unique elements in your columns, you can call n unique, and that will give you 3. So and then you can also do this. So df call 2, and then of this you can call value underscore counts, and this will return you the data of the column and the number of counts. So here we have 444 repeated 2 times, so the value is 2, while the others have the value 1. So now let me move to another useful function in the pandas data frame. So if you want to apply your own functions to the pandas data frame, so for example, let me put sums as a function name, and let me pass in x, and from that function I'll gonna be returning x plus 2, for example. So if I run this, and if I want my column 1 elements to be added by 2 using this function, what I'll be doing is calling the column 1. So if I run this, I get column 1, and then if I just put the apply function on this and supply in my function, so here the function name is sums, then you can see that all the values of my column 1 have been added by 2. So you can also use this to apply lambda functions. So lambda functions are generally used this way in the pandas data frames. So if I put x colon x plus 2, then you will get the same result. And if I put here suppose x plus 3, then the numbers are added by 3. So that's how you can use the apply function. So now let's talk about how to remove columns from the data frame. So you may have some unnecessary columns in your data frames while you're using the pandas data frame. So you can do that simply by calling df.drop and providing in as a parameter the column name. So for example, if I provide over here column 1, And keep in mind that this is actually on the axis 0, so it is actually looking at the indices for the column 1, but what we want to drop is the column, so we're going to be putting x equals to 1, and then after running this, the column 1 will be omitted from the data frame. But I won't be running this right now because I need the data frame for later purposes in this video. So now I'll just leave it there. So then let's see another useful function that you can call of your data frame, that is df.columns. so this will get you the attributes of the data frame. For example, you will get all the data column names in your data frame. So if you are ever confused in your data frame when you look at the column names and you can't make out which is what, just call df.columns and you'll get the column names back as attributes. So then you can also call df.index to get the indices. So here we have starting from 0 and stop at 4. So this goes from 0 to 3. These are the values. The stop actually denotes the values. So we have 4 values over here. 0, 1, 2, 3. So that's the range as an index. Now let's talk about sorting our data frames. Data frames can be sorted by using the sort underscore values function. So if I pass in column 2, which was this column 444 555 66 444. Now if I run this, you can see that my data is sorted in column 2 and the index has also shifted up, so keep that in mind. And then another useful function to call of your data frame is the isNull function in order to check if you have any null values in your data frame. So here I have every value in my data frame and none of them are null, so the booleans that are returned are all false. Now if you had a null value over here, suppose you would have received a true boolean over here. So now let's get to data input and output through pandas. So for this for reading and outputting data from CSV files and Excel files, you will have to install go to your command line or your terminal and just type in pip install lxml and pip install xlrd. So you can, if you are using the conda distribution of Python, instead of pip, go ahead and write conda, and over here to write conda. So after you install this, we are able to read data from our CSVs and Excel files. So now let's do that. So let me create a data frame from pd.read underscore, and if I press tab over here, you can see a lot of ways you can read data from the pandas data frame, and this is why pandas is so popular as a data analysis library. So for now I'm going to be using the read underscore CSV, and in the directory where I had the Jupyter notebook, I have a CSV named example. So if I read this and call df, you can see that I have a data frame. So this is the data frame that I had in my CSV. This is the CSV file converted into a data frame. So if I want to output this data frame into a CSV, I can just use the to underscore CSV function. Again, if I press tab over here, so I'll wait a minute. Okay, so to underscore tab, you can see that I have many data formats that I can output from the data frame to save as a file. So for now I'll be using to CSV, and then let me keep the name as output. So if I run this, I also want to show you guys another thing. So if I run this, let me quickly do this. So pd.read underscore CSV to read the output file. So what you can see over here is that in our new CSV, the index has actually been given a new column. So if you want to prevent this from happening, what you want to do is you want to supply the index equals to false parameter. So if you run this and then this, then you can see that our output CSV now looks similar to our example CSV from where we read the data frame from where we read the CSV and then convert it to a data frame. So now let's import data from our Excel file. So for this, I'm going to be naming the data frame as pdf. Then I'm going to be using the pd.read underscore Excel. I just press tab over there to self-complete, autocomplete. Then I'll be providing the Excel file name. So my Excel file name is, I think, example. So, and then the file extension. Now what I want to do is also provide the sheet name of from where I want to extract the data. So if I provide in sheet 1 over here, it will extract the data from the first work sheet in the Excel file. So now if I run this and show you what df looks like. So df, if you are confused, if you're thinking this is the same values as above, let me give it another name, dfas. So now if I run this and this, you can see that the example Excel file has been converted into a data frame. So this is how you can read Excel files. And now, like this to CSV function, you have the to underscore Excel function to output as your Excel file, the data frame as your Excel file. So let me provide it a name as sample.excelxx, and then the sheet number, sheet name, my bad, sheet name equals to new sheet. Now if I run this, sheet name, what did I do wrong over here? So let me copy this once. So that's not working for me right now. Oh, my bad, I had to actually provide sheet underscore name, and over here, then why did this work? So okay, here in read Excel you don't have the underscore sign, but in the to Excel function you had the underscore sign. I don't know why Pandas is keeping the data parameters like this, but so let's run that. No module name OpenPY Excel. So it seems that I don't have this installed in my system right now, but I'm sure if you install this and run this command again, then the Excel file will be outputted. So I hope you guys learned a lot from this video, and these functions are used widely in the real life data sets. So make sure that you guys are quite familiar with these functions and try them out for yourself to get some like experience on them. So today I'll be stopping the video at this much. I hope you guys liked this video, and if you did, and if you want to follow along, just subscribe. And also if you have any questions, just leave it out in the comment sections and I'll reply to them. So yeah, ta-da.